what is it in chemistry that you find difficult? Is it the organic? Is it the derivations? Is it inorganic chemistry, numericals?
Organic and numericals.
Organic and numericals you find difficult. Okay. So I'll make sure I focus on that. Okay. Fine. So the topic I've selected today is your very first chapter. Okay. And that is solutions. Have your classes started?
Not yet, ma'am.
Okay. So do you have any idea what is solutions from your first view?
Mixture of different solvent and solute.
Mixture of different solvent and solute. Very good. Okay. So a solution is nothing but basically a homogeneous mixture. Okay. So what do I understand by a homogeneous? A mixture is nothing but something which has more than two substances, correct, right? Two or more than two substances. Homogeneous in particular means one which has uniform concentration. Okay. So if I take a glass of water and I add a spoonful of sugar or salt into it and stir it, okay, I get a salt solution or a sugar solution. In either case, once the solution is completely mixed, I cannot separate my salt and sugar. I cannot tell one part of the glass has more salt and one part has less salt, correct? It is uniformly distributed. So two things have combined to give me one solution. Okay, so such a mixture is known as your homogeneous mixture. And solutions are nothing but homogeneous mixtures around us. Okay, and as you said, it has two components. So the two components of your solution are you have your solute and you have your solvent, correct? Now, what is a solute, what is a solvent? Now this is something we've been studying from a very long time, right? Can you tell me what is a solute and what is a solvent?
Solute is the thing which is dissolved in the solvent, and solvent is like any liquid which takes in the solute.
Can it only be a liquid?
Liquid or semi-liquid.
Okay, so the thing you need to understand here is I particularly didn't tell homogeneous liquids over here when I spoke about solutions. I told you it's a homogeneous mixture. Okay, so your solvent basically can be solid, liquid, or a gas. Okay, though in general when we speak, we refer to solutions, we tend to see at liquid solutions. Okay, so solvent is basically the component which is in larger concentration. Okay, now suppose I take a glass of water, okay, filled with water, and I put 1 spoon of sugar into it. Okay, which is in larger quantity, the water is in larger quantity, correct? So the water acts as a solvent and my sugar acts as a solute. But at the same time, if I take a bowl which is filled with sugar, okay, and I add 1 spoon of water into it, in this case what happens is the sugar and water will mix, correct? Sugar cubes will take up the water. Hmm? You can't separate it. But in this case, my solvent is sugar and my solute is water. Is it clear? Okay.
Yes, ma'am.
Okay. So there are two components in your solution basically. There is solute and there is solvent. And solvent is always in larger quantity. Now remember one thing. The physical state, whether it is a solid, liquid or gas, physical state of your solution will always depend on the physical state of the solvent because it is in larger quantity. Okay. So basically, based on that, we can divide our solutions into three types. Okay. So I have my gaseous solutions, I have my liquid solutions, and I have my solid solutions. Okay. So if I have to talk of gaseous solutions further, okay, I can have gas in gas, correct? Gas can be dissolved in gas. I can have a liquid in gas, and I can have a solid in gas, correct? So when I have a gas in gas, what example can I give you? For your air. Okay, so what is happening? There is a mixture. There is oxygen, carbon dioxide, nitrogen. Everything is mixed. Okay, so the air around us is an example for a solution, gaseous solution of gas dissolved in gas. Okay, if I have to consider liquid in gas. Okay, so chloroform. For a lot of organic reactions, we use chloroform in nitrogen gas. Okay, and for in case of solid and gas, we can use camphor or karpur. Okay, camphor mixture of camphor and nitrogen gas is an example for solid in gas. Okay, similarly, please stop me if you're not able to understand something. Okay, I have my liquid solutions. So liquid solutions are also divided based on whether it is a gas in liquid, whether I have a liquid in liquid, or if I have a solid in liquid. Okay, so dissolving gas in liquid, your soda, your fizz, whatever you see, that Coca Cola. So, what is there? It is carbon dioxide dissolved in that solution, correct, right? In that liquid, whatever is there. Or you can take example of dissolved oxygen. Your aquatic plants, animals, how do they undergo respiration? They depend on this oxygen which is dissolved in the water. Okay. Liquid in liquid, if you dilute your sanitizers, basically it is 70% alcohol, correct? No, so it has alcohol in water. Similarly, your solid in liquid. Solid in liquid can be anything. You can take glucose in water, salt in water, sugar in water. So in either cases, you're dissolving a solid in or liquid. Okay, so the third type of solution that we have is a solid solutions. So when I talk of solid solutions, again I have gas and solid, I have liquid and solid, and I have solids dissolved in solid. Okay, so gas and solid, usually you have studied your hydrocarbons chapter. A lot of times we're using hydrogen catalyst in that hydrocarbons chapter, if you remember. So this catalyst, this hydrogen that you're using, is always on a palladium. Palladium is a metal. Okay, so since the absorption capacity of palladium is very high, hydrogen is used as a catalyst on palladium. So this is an example for a gas dissolved in solid. Okay. Now palladium in small quantity can almost absorb 10 times more hydrogen on its surface. So that is why this is usually used wherever hydrogen is required for the catalysis. Okay. The next is liquid and solid. In what case are you using a liquid and solid? Okay. Suppose you have a amalgam. Amalgam is basically a mixture of mercury with some other metal. Okay. In order to get liquid-like property. Okay. So mercury is a liquid. So a semi-liquid like a property is something which is known as amalgam. It's a mixture of mercury with some metal. So this amalgam, when it is dissolved in sodium, okay, so this mixture of mercury and another metal, when it is particularly dissolved in sodium, we call it as an example of liquid in solid. And third example is solid in solid. Okay, so when I talk about solid in solid, can you give me any example? Can you think of anything? Any two metals that are combined together? Okay, I'll just tell you. Your ornamental gold, okay, the gold which you get in shops. Have you seen they never sell 24 carat chains? It is always 22 or 18 or 20 carat, whatever. Now, this is simply because gold as such is very delicate, okay, that 24 carat pure gold. And when this gold is mixed with copper, okay, that is when its purity decreases and its strength keeps on increasing. So it is basically gold is in larger quantity here, so it is copper in gold. Okay, similarly your brass, Your brass is nothing but a mixture of copper and zinc, and your bronze, those medals that you get, they are a mixture of copper and tin. Either of which, all are examples of a solid dissolved in a solid. So, is it clear till here? See, these examples are very important because repetitive questions have been asked over the years where they give you one of the example. It is a direct question, and they ask you what kind of a solution it is, and what is the solute and what is the solvent. So usually for 2 marks and for 1 mark, these kind of questions are asked. Okay. So do you have any doubts? Can I continue?
Yes, ma'am, no doubts.
Okay. So now you understood what is a solution. You understood the components of a solution. Okay. Now I told you solution usually has two components. It can be it has a solute and it has a solvent. Okay. Now any solution can have one solute in a solvent. It can have two solutes in a solvent, three solutes in a solvent. Accordingly, your solutions are divided as binary, trinary, tertiary solutions. Okay. So in this particular chapter, we are going to focus on binary solutions. Okay, so whatever examples we learned till now are all examples of binary solutions. We need to remember that. Okay, so there is only one solute and one solvent. So throughout the chapter, we are going to talk only about these binary solutions. Having known that, the next thing that we have to learn is now that you know what is solution, what is that? What is a solution made up of? What is a solute and solvent? What are the possible different solutes and solvents that we can have? Let us just look into how can we tell about the concentration of a solution. Okay. So concentration of a solution has two methods. You can either tell it qualitatively or you can tell it quantitatively. Okay. Can you tell me what is qualitative and quantitatively? You have studied in first PU, right? What do you mean by qualitative analysis and quantitative analysis? You have done your salt analysis in first PU, right? Okay, I will tell you. So basically, uh, qualitative is based on the quality. Okay, I'm not sure if you have done your salt analysis. We usually started in the first year, but here what is happening? You are given a salt, okay, and you have to find out what is that salt. Just the, what is there. You're not supposed to find how much of that is there. Okay, but whereas when you're doing your titrations, if you see, you are finding out what is the concentration, how much of your unknown solution is there, correct? So just finding out what is there is your qualitative analysis, and finding out the quantity, how much is there, is your quantitative analysis. Okay, so concentration of a solution in general is told in a qualitative manner. Okay, suppose I have one glass which has 1 spoon of sugar and one glass which has 10 spoons of sugar. So I will definitely tell glass B is more concentrated than glass A, correct? So I'm just telling you, compared to one, the other one is more concentrated or more dilute. Okay. But when I come to my quantitative analysis, here I am trying to basically tell you how much, exactly what is there. Okay. So quantitative analysis of your salt is basically you have 7 types of methods to express how much a concentration of a solution. Okay. The first one is you have mass by mass percentage or mass percentage. You have volume percentage. Please focus on this part from your competitive exam point of view. This is very important, okay? You have mass by volume percentage. You have your parts per million or ppm. There is mole fraction. molarity and molality. Is it clear? So we have 7 methods which are very important for you to learn. I'll explain each one of them to you, okay? So the very first one is mass percentage, okay, or mass by mass percentage. So in general, tell me, how do you find percentage? Your marks or whatever, how do you find percentage?
Divided by 100.
Divided by 100. Is that how you do it? See, percentage is always given amount, okay? You're given
Given
marks
amount by total amount into 100.
by total amount of marks, whatever, into 100. So this gives you your percentage, okay? In mass percentage, what we are saying is you want to see which component you have, whether it's the solute or the solvent. So whosever mass percentage you want to see, you see mass of that component or mass of a particular component divided by mass of your solution, okay? Whole thing into 100. So it's a very straightforward formula. Mass of the component you're interested in, whether it's a solute or solvent, divided by mass of the total solution, both the solute and the solvent, into 100. Okay. Suppose I tell you I have dissolved 20 grams of glucose in 80 grams of water. Okay. Can you find the mass percentage of glucose and water? See, in case of glucose, I will tell you. For glucose, the mass percentage is, okay, mass percentage is represented as W by W, okay? So mass by mass is equal to mass of glucose divided by mass of my solution. So solution contains glucose and water, 20 plus 80 into 100. This is nothing but 20%, okay? Similarly, what will be the mass percent of glucose? Can you tell me? For water, can you tell me?
100 by 20.
Of only water. 100 is of your solution, remember. So your solution has glucose plus water. 20 plus 80. I'm asking you only of water.
80 by 100 into 100.
Put 80 by 100 into 100, which is nothing but
80.
80%. So is it clear? Mass percentage is clear to you?
Yes, ma'am.
Okay. So the next one you have is volume percentage or volume by volume percentage. Okay, so volume percentage is represented as capital V bar capital V. This is how you represent it. Okay, again it's same over here. What did you use? You used the mass. So one thing you have to be careful. Sorry, I didn't mention this. If at all, the SI units of both your solute and solvent have to be the same. Okay, remember that, or else you'll have to change it and do. So, what have we used here? We have used mass. So, in case of volume percentage, it is nothing but volume of a component, either solute or solvent, up to you, divided by total volume of your solution. Whole thing into 100. Okay, so you have a volume of component by total volume of solution into 100. Suppose, let me give you an example for your understanding. I have dissolved, okay, 15 ml of ethanol in 85 ml of water. Okay. Now, if I have to consider the volume percentage of ethanol, what will I do? What is the volume of ethanol? I know it is 15 ml. Correct, right? Total volume of my solution is 15 plus 85. Correct? I have 15 ml of ethanol, 85 ml of water. Whole thing into 100. Okay. So again, I end up getting 15%. Okay. But on the other hand, if I tell I have dissolved 25 ml of ethanol in 250 ml of solution. Okay. In this case, can you tell me the volume percentage of ethanol?
25 by
250 ml of?
275. 275.
Why did you do 275? Have I told you it's a solute or solvent?
Oh, okay, okay.
Okay.
It is
Understood?
250. 250
Into 100.
into
Okay.
100.
So either way, you get 10%. Did you get it now?
Yeah, yeah, I get.
Okay.
Yeah.
Be very careful when you read your questions. These are the easiest numericals that you will get, but at the same time, they are very tricky. Okay. Sometimes they give you the solvent. Okay. If they mention just water or something, it is
Okay,
always a solvent. But if they
okay,
have mentioned solution, you need not add the solute to it again. Okay.
okay, okay. Got it.
Okay. You got it. Okay. So the next representation that we are going is mass by volume percentage. Okay, so mostly numericals are not asked in this particular range of concentration. Okay, simple reason, it is usually used in your pharmaceutical